Hi, Rockstars. Today we will be advancing in our chemistry ignition series. In the last class, we talked about the first part of the introduction to chemistry, where we introduced physical and chemical change and nature of matter in general. In today's class, we will be advancing to second section of the introduction to chemistry, where we'll be talking about separation techniques. This class will be split into three different sections. In the first section, we will introduce the concept of separation techniques, in which we will be listing the separation techniques and explaining them. In the second section, we will be addressing the test for purity, and thirdly, we will be using this knowledge to crush UTME questions. Stay with me. Greetings, future rockstars, and welcome to Josh White Academy, where we fuel your success with experience-backed strategies and science-based tutorials. If you are new to this channel, I am your host, Josh White, and it's my mission to help you crush high school with confidence and clarity. So please do well to smash that subscribe button, turn on the notification. Let's get started. Okay, in the last class, we introduced element, compound, and mixture, and we talked about mixture as a substance that comprises two or more constituents that are physically combined together. Now, one being able to separate the individual components of a mixture requires a special technique, which is a physical method known as separation technique. We use the principle that every component in a mixture do not lose their individuality when forming that mixture. So, separating each component of a mixture requires a physical means known as separation techniques. So, separation techniques are physical methods used in separating the components of a mixture. Now, there are several separation techniques, and we'll be taking many of them. Number one, we have sieving. Number two, we have decantation. Number three, we have magnetic separation. Number four, we have centrifugation. Number five, we have evaporation. Number six, we have crystallization. Number seven, we have fractional crystallization. Number eight, we have filtration. Number nine, we have distillation. Number 10, we have fractional distillation. Number 11, we have flotation. Number 12, we have sublimation. Number 13, we have precipitation. Number 14, we have chromatography. Number 15, we have funnel method or separating funnel. So these are very important separation techniques that you should take note of. Now, sieving. Sieving is used to separate solids of different size by using a sieve. Industries that use sieving are like the mining industries, where they mine for gold and diamond. So they use sieving method to obtain certain precious stones. Also in the milling industries, where they use a sieve to separate the grains from the chaff. Now we have decantation. Decantation is used to separate a solid that doesn't actually dissolve in a liquid, that when allowed to stand, they form two different layers and they are separated by merely pouring out the top liquid, simply known as decantation. We use this most times when we soak our groceries, our gari. So the top part of it, we pour it out. That's simply decantation. But you know, this method is very fast but inaccurate, because many times the agitation of the solid always goes, it makes the solids to also be decanted alongside the liquid. The next one is magnetic separation. Magnetic separation is when we use a magnet to separate magnetic substance from non-magnetic substance. We use this in separating certain metals such as tin. Yeah. Then we have centrifugation. Centrifugation actually uses the principle of a centrifuge machine wheeling around at certain frequency, a certain speed, and as it is wheeling around, there are test tubes inside it with the mixture. So the heavier solid particles goes down, whereas the lighter ones remain up. Most times we use this separation technique where the mixture is in limited or in small amount, most times in medical industries. So for example, I want to take the PCB test. Now, pack cell volume. Now, the test tube, the centrifuge tube looks something like this. So a blood is taken from the patient or the subject and placed in the centrifuge tube and placed in a centrifuge machine and balanced so that it doesn't spill. And also sealed. So after it wheels, you will notice that there will be a clear liquid at the top. Then there will be a buffy coat around the middle, and lastly, we will now have our red blood cells down here. So this is our red blood cells. This is our blood platelet and white blood cells. And this top, which is a pale yellow color, is our plasma, the liquid portion of blood. So we just measure the PCB by taking note of the RBC count. That's the PCB, packed cell volume. So we use centrifugation to separate the different constituents of this mixture as blood. The next one is evaporation. Evaporation is used to separate a soluble solid from its solution by heating it to dryness. So for instance, industries like salt making industries, like our Dangote in Africa and Bua. So they obtain water from the sea or ocean that has high level of salt. The salinity is very high. So they apply, they keep it in a tank and apply heat to it. The water evaporates, leaving the salt behind. So that is the salt. That's where salt or the metal salt is being extracted from seawater, and possibly other supplements are added like iodine. Yes. So that's evaporation. Next one, crystallization. Crystallization is very similar to evaporation, but it is used to separate salt or obtain salt or solid from a liquid that easily decomposes on heating. So you can't heat this kind of solid to dryness without it being decomposed. So you use a method known as crystallization. Now, what you do is, let's say for instance, you need high level of purity, because this technique is used by drug making industry, where high purity is needed, or even in sugar companies. You know, you can't heat sugar to dryness. When you squeeze out the sucrose, that's the cane sugar from sugar cane, if you heat it to dryness, the sugar will decompose, will change from white to a brown color. So you can't follow evaporation, you follow crystallization. So now what they do is they will apply a little heat to make the solution to become saturated. After doing that, then they will now seed the saturated solution with that same solid they want to crystallize out, and then crystals, solids, then form out of the liquid, or by scratching the inner surface of the vessel in which the liquid is inside. It stimulates crystallization. Now, most times when solids come out from this same method, they always come out with water of crystallization. Example, we have our copper 2 tetraoxosulfate 6 pentahydrate. It has 5 water of crystallization. We also have copper 2 trioxonitrate 5 trihydrate. We also have iron 2 tetraoxosulfate 6 heptahydrate. 7 molecules of water. So that's crystallization. Now, fractional crystallization is when there are multiple solids in that solution or in that mixture. So their solubility differs in different temperature. So in changes in temperature, different solid in that mixture crystallizes out. So fractional crystallization is used where there are multiple solids that easily decompose on heating to dryness. Then we have filtration. Filtration is a separation technique where a porous bed like filter paper is used to separate insoluble solid from a liquid. For instance, let's say our chalk suspension, we ground the chalk and mix it with water, and that forms a suspension because chalk is not soluble in water. So if you pour that in a filter paper, the water will pass through it because the molecule of the water is smaller than the space of that filter paper or filter bed. But the chalk, whose molecule is larger, will be captured by the filter paper. The ones that pass through are known as the filtrate. The water is the filtrate, whereas the solid that is trapped in the filter paper is known as the residue. So you use this to separate a solid that's not soluble in the solution. Also, like sand and water, we use filtration. So a company that uses this filtration, like our water company, using purification of water. So the next one is distillation. Distillation is used to separate two mixable liquids by taking into consideration their differences in boiling point. Distillation looks like, okay, let's say for instance, two mixable liquids are like alcohol, ethanol, and water. You can't know their difference unless you perceive it, because water is odorless, but alcohol is scented, it has odor. So alcohol boils, the boiling point of alcohol is 78 degrees Celsius, whereas the boiling point of water is 100 degrees Celsius. So if I want to separate a mixture of ethanol and water, it's through distillation. So I put my mixture inside here. I put a thermometer to give me my temperature readings. I connect this tube then to another vessel here. And at this place, I put an ice badge or circulating water so that this region will be very cold. Now, this is the mechanism. As I begin to apply my heat through my Bunsen burner, as I begin to apply my heat, this thermometer, the mercury in it begins to rise. When it reaches 78, it will stop, and the mixture will be boiling. At that temperature, what is boiling is not actually water, because water does not boil at 100. It's ethanol that is boiling. So remember, when the boiling point of a liquid is reached, it begins to evaporate, changing phase, changing state from liquid to gas. So ethanol begins to form gas. As the gases, the vapor begins to rise to this point. Remember, this region now is very cold. It will lead towards a conversion of state from gaseous state to liquid state, a phenomenon known as condensation. So the gas will now then be condensed back to liquid and collected in the next vessel. So you will continue. You will notice that when the thermometer reading goes above 78, the solution will stop boiling, because all the ethanol has been collected, so it will stop boiling. So by that way, you've been able to successfully separate ethanol from water. So that is distillation. It's used to separate two mixable liquids by taking into consideration their differences in boiling point. And please take note, for distillation, the space between the boiling points must be far apart. If they are very close, you can't use distillation. That brings us to the next separation technique known as fractional distillation. Fractional distillation is used to separate more than two mixable liquids. Same format. The only difference between the apparatus setup for distillation and that of fractional distillation is that in fractional distillation, there is a column known as the fractionating column. Is absent in distillation but present in fractional distillation. Let's say, for instance, our crude oil, petroleum, it has a lot of fractions in it. We have kerosene, we have bitumen, we have petroleum jelly, we have petrol, we have diesel, many. So, to separate this, we use a fractionating column. Still the same format. The upper parts are at lower boiling point, whereas the lower ones are at higher boiling point. So, the ones with the lower boiling point are first carried. So, at different sections, there are troughs. They are like basins that are at different boiling points. So, when a particular fraction reaches where its boiling point reaches, it is collected there. So, the fractionating column helps to separate the different fractions by making the different layers of that fractionating column to be at different temperature. So, the fractions with the lower boiling point are collected first before the ones with the higher boiling point. So that's fractional distillation. Now, before moving to flotation, let's take funnel method. Now, funnel method, unlike distillation, funnel method is used to separate two immiscible liquids. Now remember, distillation is used to separate two mixable liquids. Funnel method or separating funnel is used to separate two immiscible liquids. For instance, palm oil and water, or kerosene and water. In a vessel, you will notice that water has a higher density than palm oil. So palm oil is found above water. So let's look at this palm oil, and this is water. You can do this locally or at home. You will just make a little opening down. You will notice that the water will be dropping. This vessel must be transparent so that you can see the two different faces. As the water is dropping out, as all the water have dropped, then you will close it, you will seal it. By that way, you separated the palm oil from water. Simple. That's funnel method, or separating funnel. The next one is flotation. Flotation is actually used to separate certain ores, low-graded ores. So certain ores are actually extracted, and before the metals from the ores can be removed, those ores must be concentrated. Most times these ores have impurities of sulfides mixed or combined with earthly impurities. So to be able to concentrate these ores, what they do first is you will ground these low-grade ores to powder, mix it with water and air. It will form a foamy, frothy suspension. When allowed to stand, you will find out that the weighted earthly impurities will go down, whereas the ores that are unweighted will form the suspension. So it will then be separated by filtration. The suspension then is what contains the ore that has been upgraded, the ore that has been concentrated. Then it can be then used then to extract the metal. So that's flotation. The low-graded ore is grounded to powder, mixed with water and air. Then it is then filtered to obtain the ore. The next one is sublimation. Remember from our last class, we defined that the phenomenon whereby solid transforms directly to gas, or gas transforming directly to solid without passing through the liquid phase. That phenomenon is known as sublimation. So we use sublimation as a separation technique when one of that mixture, one component of the mixture, sublimes. Example is our ammonium chloride, locally known as CAM4. When a little heat is applied to this solid, it changes directly to gas without passing through the liquid state. So that separation technique is known as sublimation. We use an inverted funnel. Then we put the mixture containing the solid that can sublime, and we apply a little heat. Close here with a cutting board or tissue paper. You will notice that chloride will begin to form solid around the edges of this funnel. So that's a way to separate a solid that can easily sublime using sublimation. Next, we have precipitation. Please take note, for exam purpose, precipitation is the separation techniques that require a chemical process. Remember, we define separation techniques as a physical method used in separating the components of a mixture, but precipitation is a chemical process. So it can be asked, among all of the following, which one uses a chemical process in separating the components of a mixture? The answer is precipitation. Precipitation uses the differences in the solubility of a solid in two mixable liquids. Now, for instance, iron sulfate is soluble in water but insoluble in ethanol. iron 2 tetrahydrosulfate 6. Iron sulfate is soluble in water but not soluble in ethanol. And ethanol and water are both mixable. So, if we have a solution of iron sulfate in water, like the one we said before during crystallization, iron tetrahydrosulfate 6 heptahydrate, it has water, and we want to form a crystal of iron sulfate, we want to form a solid of iron sulfate. All we need to do is to put ethanol into that solution. You know, ethanol mixes with water. So what will happen is the ethanol will go and take up the space that iron has taken in water. By that way, it will make iron sulfate to come out as precipitate. Remember, iron is soluble in water. But when you bring alcohol, ethanol inside, the ethanol goes to mix with water, making iron sulfate to come out as solid. That process is known as precipitation. Differences in solubility of a solid in two different mixable liquids. Lastly, chromatography. One way to remember the function of these techniques is to remember this word chroma. Chroma means color. Chromatography is used to separate the components of a mixture by taking into consideration their differences in the rate at which they move in an absorbent, like in the case of paper chromatography or column chromatography. We also have gas chromatography. Most times, when you desire to know the different components of a color, you use this process called chromatography. It involves a chromatography paper, which is our absorbent. So you place your pigment here and place this in a solution that can easily move up by capillarity. So as this liquid begins to rise up this absorbent and comes in contact with our pigment, it continues moving and it will be dropping different color changes as it moves up. So by that, you will know the different component colors that make this pigment. That process is known as chromatography. So let's move to the second section of this class, the test for purity. To test for purity, there are three important things to take note. Number one is the boiling point. Number two is the melting or freezing point. And number three is through chromatography. Now, every pure substance have a definite boiling or freezing or melting point. For example, pure water or distilled water boils at 100 degrees Celsius and freezes or melts at 0 degrees Celsius. But if there are impurities in that water, let's say for example salt solution, salt is inside the water, it makes it to boil at above the boiling point because impurity and pressure increases boiling point but lowers the melting or freezing point. Now you can go and try this. Take two different containers. One of the containers put pure water inside and the other put salt solution. The water you put salt inside and heat the both of them. You will notice that the pure one will boil faster. It will start boiling first before the impure one, because the impurity in it has increased the boiling point. And carry that to the same containers and put them into the fridge. You will notice that the pure one will turn ice block first before the impure one, because also impurities and pressure lower the freezing point. Also, in polar regions where rivers and lakes can become ice, they have a way of removing the ice from the street by applying salt, because salt knows how to lower the freezing point of water, making the water to melt. So that's a way to test for purity. If a substance has a range of boiling point or melting point, it means it is impure. It's a mixture. It must have a definite boiling point and melting or freezing point. Now in chromatography, to know if a pigment is pure, it has only one fraction. When you put it in a chromatography paper, it will deposit only one color. It means that that pigment is pure. Now, can we use this knowledge to go and crush UTME questions? Come with me. One of the following techniques can be used to show that chlorophyll 2 pigment is a mixture of chemical compounds and not a single colored compound. I said this in the last separation technique. Anywhere you come across colored compounds like chlorophyll 2, which is a green pigment found in plants, in green plants, just know that your answer is what? Chromatography. Don't stress. The next question. The presence of impurity in a solid will make the melting point to, remember in our test for purity we said impurities and pressure increases boiling point and decreases melting or freezing point. So the presence of impurity in a solid will make the melting point to what? To increase. The next question. Rockstars, if you've been enjoying this video thus far and you have not subscribed, what are you waiting for? It doesn't bite. The subscription button is there. Please do well to hit the subscribe button. By that way you will encourage us to make more videos to be of help to you. Let's continue. The separation technique that is based on the principle of solubility of a solid in two mixable liquids is, remember we said this when we talked about iron sulfate in water and ethanol. That's precipitation. The separation technique that requires a chemical process. So it is used to separate a solid that is soluble in one but not soluble in the other, and both liquids are mixable. So our answer is what? Precipitation. So the next question. The chromatographic separation of ink is based on the ability of components to, we said this in column or paper chromatography. The principle is the difference in the rate of movement of the different components of that mixture. So our answer is the movement at different speed in the column. That's the principle. The rate at which the different components move on that particular column or paper. So that's the answer, option D. Now let's take the final question. In countries where the temperature falls below 273 Kelvin, this is the same thing as 0 degrees Celsius. Salt is always sprinkled on the icy roads in order to lower the melting point of ice, increase the density of ice, make the ice impure, raise the melting point of ice. Remember, please do not forget this. Impurities increase boiling point but decrease melting or freezing point. As I said in the test for purity, in countries or cities like this, salt is sprinkled on the road to lower the melting point or freezing point of ice, to make the ice to melt. So our answer is to what? To lower the melting point of ice. So, rockstars, if you truly enjoyed this video, please give it a thumbs up, like it, subscribe, comment in the comment section, and also do it to share it so that it can also reach out to others and be a blessing to them as it has to you. In the next class, we will be moving forward and we will be talking about the theory of atoms. We will be talking about atoms. You can't afford to miss that class. Please, if you are struggling or you know anyone who is struggling with chemistry, please come to Josh White Academy. We have you covered by God. So, I remain your host, Josh White, leaving to catch you another day. Shalom.